Hypothesis testing. We'll begin by defining what is a hypothesis. It is basically a blunt statement about the population that mostly expresses the researcher's predetermined opinions, inclinations, observations, or non-substantiated response to a research question. It serves as a possible answer to the research question before empirical data is collected. So a research question must be posed about the population, and then you have a response, which is called a hypothesis, and then a sample data has to be collected to prove or disprove that hypothesis. In other words, the hypothesis has to be tested to see if it is correct or not. The following is a flowchart illustrating the fact that the hypothesis is an attempt to answer the research question about the population before data is collected from a sample. So first, you have a research topic, which is about the population. For example, a study of the significant factors that influence the learning of mathematics. And then comes a research question. Again, it's about the population. For example, is there a significant difference in mathematical abilities across gender? Now comes the hypothesis, commonly called the claim, which is again is about the population. So a response to such a question could be, there is no significant difference in mathematical abilities across gender. Or another response could be, there is a significant difference in mathematical abilities across gender. We'll come to in more detail about these two types of responses. But the fact is that the immediate response after the research question is called the hypothesis. So the objective, just to continue, the objective now, which is about the population, is to determine if there is a significant difference in mathematical abilities across gender. So now comes statistics now, and a sample data has to be collected, organized, represented, analyzed to decide and conclude either with the claim or not. Okay, so the variable here identified is the mathematical abilities. So a claim was made in the line of males performing differently than females in mathematics, or performing the same. Now, please be aware of the fact that the population claim is directed towards the entire population of males and females. However, the statistics now starts with the collection of data from only a sample in order to conclude or not with the claim, the hypothesis. So the important point is the hypothesis comes after the research question. It's an attempt to answer the research question before data was collected. Now, there are two types of hypotheses. The null hypothesis with symbols HO or H0, and the alternative hypothesis, symbols HA or H1. So here, let's put a little focus on the null hypothesis, HO. A null hypothesis is a type of statistical hypothesis that proposes that no statistical significance exists in a set of given observations. So the null hypothesis will always be saying no. One can say that it is the statement of neutrality. Also, it can be said that it is the status quo. I normally call it the conservative statement because it's always saying no, no significance. It is used to assess the credibility of a hypothesis by using sample data. So sample data has to be collected and processed and then matched to the null hypothesis. Actually, it is the statement to be nullified. So either when you process the data, either you reject the null hypothesis or you do not reject the null hypothesis. The test will begin assuming that it is true. So the test will always begin by assuming that the null hypothesis is true. And at the end, it will either be rejected, nullified, or it will not be rejected. So a research question is asked, first and foremost. Two persons attempt to answer the question off the bat. What are the names? The null and the alternative. The null will always take the neutral stance. For example, research question, what is the population average? Now, this will be a single sample z-test or t-test for population mean. The null will respond by saying there is no difference between the population mean and the sample mean. And please be reminded, for the z-test and the t-test, the null hypothesis will always carry the equal sign. Never forget that. Please pause the video, rewind, read again, so that you can learn more about what is being communicated. Here's another research question. Is there a factor affecting the distribution? So that would be a chi-square test for randomness. The null will respond that question by saying there is no factor affecting the distribution of the variable. Okay? Taking the neutral stance, that's a null for you. And the alternative will take the opposite stance. But the null will say no factor affecting the distribution. Here's another example. Is there a significant difference between what is expected and what is observed? That would be a chi-square test for variation. The null will respond by saying there is no difference between what is being observed and what is expected. The alternative will say on the contrary, and then data has to be collected to see which of the two is correct. Here's another example. Is there a significant association between variable A and variable B? That will be a chi-square test for independence or a chi-square test for no association. The null will respond by saying there is no association between variable A and variable B. So as you can see, the null hypothesis is a statement of neutrality. It will always take the conservative standpoint. No difference between population mean and sample mean. No factor affecting distribution. No variation. No association between the two variables. So here we have a little focus on the alternative hypothesis, symbol HA. The alternative hypothesis will contradict the null hypothesis, which will always state insignificance. So the alternative hypothesis will always state significance. It will be opposite to the null hypothesis. Here are some more explicit examples. Research question number 1. What is the average mathematics score of nursing students of semester 2, 2023? So the null will always respond, well, the average mathematics score of nursing students of semester 2, 2023 is equal to 80%. And here, because this is a test with regards to population mean, this statement will be translated to symbolic form. There is a symbol for population mean. Mu is equal to 80%. That's what the null will always say. For that type of test, the null statement will always have the equal sign. Now, the alternative statement will say, for example, the average mathematics score of the nursing students of semester 2, 2023 is greater than. So the alternative can say is greater than, is less than, or not equal to 80%. And again, this has to be translated to symbolic form. Is greater than, is less than, and is not equal to. So the alternative would either say either one of those three, greater than, less than, or not equal to, but the null will always say is equal to. Research question number 2. What is the relationship between distance from school and academic performance? So the null will always respond by saying there is no correlation between distance from school and academic performance. And the alternative will say, for example, the correlation between distance from school and academic performance is strongly or weakly negative or strongly or weakly positive. But the null will always say no correlation. Here's a third research question. Is there a significant association between academic major and mathematics performance of college students? So the null will always say there is no significant association between academic major and mathematics performance of college students. The neutral one, the conservative one. Whereas the alternative will say there is a significant association between academic major and mathematics performance of college students. So therefore now data has to be collected to see which of these two statements is going to be the conclusion. Here's a fourth example. Is there a significant difference in mathematical performance across gender of college students? So the null will say there is no significant difference in mathematics performance across gender of college students. And because this is a z-test or t-test for population mean, that will be two samples z-test or t-test, then the statement has to be translated to symbolic form. So the null statement will be saying the population mean. Here's a symbol for population mean, that's mu, a Greek letter. The population of males is equal to the population mean of females. Whereas the alternative null will say there is a significant difference in mathematics performance across gender of college students. And this can be expressed in three ways. One way is by saying, well, the population mean of males is not equal to the population mean of females. Or the population mean of males is less than that of the population mean of females, or the population mean of males is greater than that of the population mean of females. So either one of these three, the alternative can respond, but the null will always respond by saying there is no significant difference, and data has to be collected to see which one will be the conclusion, either the null or the alternative. Now here's a hypothesis testing flowchart. So first you have to state a pair of hypotheses, the null hypothesis and then the alternative hypothesis. Now you've got to, after you have done that, you've got to state the significance level, which is a probability value called alpha. You have to calculate the test statistic, obtain the critical value, and you have to obtain what you call a p-value. Then you can either take the critical value approach or the p-value approach. If you take the critical value approach, you have to complete what you call a fully labeled distribution curve. On it, there must be rejection region shaded. There must be a critical value on the critical point, and there must be a test statistic. So the test statistic can either be in the critical region, which is the shaded region, or not in the critical region. So you have to decide to reject the null if the test statistic surpasses the critical value and is encountered in the critical or rejection region. Otherwise, you do not reject the null hypothesis. And the p-value approach, you simply compare the p-value that you have obtained with the significance level that you stated, and you decide to reject the null if that p-value is less than the significance level. Otherwise, you do not reject the null hypothesis. So in conclusion, if the null hypothesis is rejected, then you have to conclude with the alternative. Otherwise, you will have to conclude with the null hypothesis if it was not rejected. So you have to pause the video, take a screenshot of the flowchart, rewind it, study it, together with the entire presentation to fully understand what is being presented with regards to hypothesis testing. So as you can see, the sample data is always linked with the null hypothesis. Either you reject the null hypothesis or you do not reject the null hypothesis.